Hi guys, welcome to Learning Electronics Repair. This is the DAS18 amplifier, not quite fitted together, so we'll just move that so it doesn't fall off. This thing, okay, so this is the power supply, the one that I eventually repaired on about the third attempt, having figured out that the MOSFETs from AliExpress were fake. Okay, so I got some from LCSC and now it works. Previously on Learning Electronics Repair, as they say, I also diagnosed there was a fault on the amplifier board. So this is the amplifier, fits in here actually, I think the other way up, but anyway that's where it goes. And this had short circuit MOSFETs also on the output. So this is bridged amplifier, two amplifiers with a pair of MOSFETs on each, okay, class D. So this video, we're going to look at that to see, now is the power supply working okay with the amplifier. I make some tests to make sure it's not going to blow up again, and then, yeah, we'll see. So I lost the first bit of the recording, basically. Never mind, I know what the problem is and I can fix it, so this is not going to keep on happening. And for once the problem wasn't me, it is equipment, okay? But anyway, while we're here, just talk about it. I don't manage to repair this in the end. I do find out what's wrong with it. I don't have all the parts. If you want to watch, you'll see. So this, even now, still isn't a completed repair. I think the next time will be. But if you'd like to see how I diagnose the problem on this, yeah, I think you might enjoy this. Okay, so let's carry on from here, watch the video. And the output from here is what powers this, so we can see these thick wires. This is the plus ground and minus input onto the amplifier. The other ones, by the way, are the plus and minus 15 for the mixer section and for the input of this board. And I think that the short circuit device on here is what blew the power supply up, okay? So I'd like to be able to prove as best I can that this is not going to blow up again. Now the best way to do that is to power it up externally. So from my bench power supply, I don't have 60 volt power supplies. I mean, I probably have enough to connect 4 in series and get a plus and minus 60. But I think if I put plus and minus 30 onto here, I have a dual power supply. I can do that. I can set a current of about 1 amp or something like that. Put a current limit on, and I can power this up at least with about 30 volts plus and minus. And if it just sits there not really drawing any current, then I'm happy enough to connect it to the power supply and we'll see what happens. Here is my power supply. This is the dual one. So it's a dual 30 volt, 3 amp. You can have them independently as 2 voltages plus another 5 volts output fixed here as well. Okay, or you can have them in parallel, giving you 30 volts at 6 amps, or you can have them in series, and then you can have it connected up plus and minus, well, 31.5 is the maximum actually. So we'll use this. Now what I need to do is connect that to here. I'm going to use some crocodile clip leads onto these, okay, and I want to set a current limit. So basically, if anything bad is going to happen, it won't be too bad, I hope. To set the current limit, I'm just going to connect the plus 30 and the ground together, switch it on, and you can see we have about 700 milliamps there, okay. I can do the same on the negative supply as well. Connect the negative to ground, switch it back on again. Yeah, I have a similar thing, about 700 milliamps, just over, okay. So that's got the current limit set to something reasonable. Yeah. You can see the current limits are both independent on the plus and minus. So what I can do now is connect it to my amplifier and see what it does. So there we have it. Let's switch the power supply on and see what the current meters tell us. And it says that it's drawing basically nothing, which is what you would expect, to be quite honest, because there's no signal on the amplifier. There's no drive, there's no plus and minus 15, but it's okay. We can put the voltage on and it doesn't have any adverse effects. So let's put this together now. We can see the lights limit signal on. Again, I'll just power this up with a light bulb in circuit. It probably won't go quite so dim because the amplifier is attached. It shouldn't come on brightly. So once again, light bulb over there. Take no chances with this thing. It's caused me far more trouble than it should have done already. Let's switch it on. Yeah, again, so on is lit up. Signal and limiter off. So that looks good. Right, we'll attach a speaker and an audio source. We'll switch the light bulb limiter out and let's see if this works now. Okay, and what happens? I have a signal coming from the mixer, but no audio. That's interesting. Okay, let's just check if there isn't something silly going on here. So I'll connect to my full range speakers, the one I normally use, rather than this sub, just in case there's a problem with that or the cable. Okay, really want to hear if there's any audio, to be honest. So this is with my speaker attached. Again, power up, on. No, there's definitely no sound, so that's pretty much eliminated that. Right, so let's get the handheld scope and let's just see if we can make some quick checks on this. Interesting. I just want to check a couple of other things. So that 7 volts I saw on one of these, I want to see if that's coming from that end of the cable. So I've just connected my black meter lead onto here. Power up again. Okay, so there's about 8.7 volts on there. That's what I saw on the scope. And nothing on that one. Okay, interesting. And if we look on the actual mixer, we have about 0.01 and nothing on there. Okay, so I may have two problems here. One is the 8 volts something on one of the cables here, which seems wrong to me. Okay, and the other one is whether the preamp is working. Now this is from a sub, so you can see the crossover frequency is set here, low pass, between 60 and 160 hertz. I've turned that up to the highest, 160. Okay, I've set the signal generator to 40 hertz, so that should pass through. If I use a higher frequency, it's not going to come through anyway. I've just attached the ground clip there to my scope. So we'll switch this on again. Okay, blue lights on and green lights on. I have a signal. If I go to the input, let's have a look. So nothing on there. Okay, it's here. Just hit auto. Yeah, so it's not telling me what the frequency is on the screen, but is it on this one as well? Should be on both channels if I have a good connection. Yeah, it's on there. Well, that actually says it's at 29 hertz, 34 hertz. Okay, it seems a little bit iffy measuring the low frequency, but it has a signal. Yeah, 29 hertz. I mean, maybe the sound card on my computer isn't very accurate with its output. So what's coming out of here? Nothing on there. We have a signal. 34 Hertz, 40 Hertz. So that's on this pin. This is the one that doesn't have that funny voltage on it. Okay, it's saying 40 Hertz in actual fact. So it's up to there. That's okay. I'm going to plug this back on again. Okay, and I'm going to check to see if I still have that signal when it's attached to here. Okay, so switch it on. Yes, I have a signal, 40 Hertz. Okay, so the signal is getting out of here into that amplifier. Right. The next place I'd be interested in looking then is on the speaker out. Now, this is probably a bridged amplifier. I think it is bridged in actual fact. But if I measure from ground on my isolated scope just to one of the speaker outputs or the other, I should see a signal if the amplifier is working. Okay, so let's have a look. I'll go on to times 10 because I don't know how high the voltage is going to be on here. Set the scope. Times 10. Okay. I'll zoom that down a bit. You can see it a little bit clearer. There you go. Look. Okay. So I'll go on to one of the speaker outputs and let's have a look. And there's nothing there. Okay, go to auto. Don't see anything. Go to the other one. Don't see anything. Okay, practically nothing. So the problem appears to be on the amplifier board. I've got a signal going into it. I mean, I can just double check there's a signal on the other end of this wire, not a stupid break on the wire. You know, guys, these things, stupid things like that, will catch you out. So we can measure to here. Okay, switch it on again. I'll put it back on to times 1 for the sensitivity. Okay, so we're back on there. Times 1. Scope probe on times 1. So here. Yeah, what do we have? We have a signal. Okay, there. So the 40 Hertz signal is getting into the amplifier, just nothing coming out from the other end of it. Something which may or may not be relevant, but I'll show you, is this is switched off and the capacitors on the power supply are discharging. The positive is down to 12 volts now, but the negative is still at 24 volts. So it's discharging faster on one side than the other. Whether that is, again, normal behavior or indicates some problem on the load, this I don't know, but it is interesting. Yeah, okay, so here's the amplifier module. I know I had short circuit output devices, they've been changed already. I haven't looked at it any more than that, to be quite honest. It shouldn't be too difficult to work on this because I can get the power supply bracket here. Yeah, I can probably arrange this in such a way that I can actually power this up from the power supply. Yeah, it might be better if I just extend these 3 high voltage wires actually and get that away from there a bit. Yeah, I'll find a way. So I'm sure I can actually power this up like this. What do we have? Let's have a quick look around it. So audio input has a strange voltage on it. We know that. Okay, that's the first thing we know. I don't see any components on the other side of the board. There's tracks on there, but I don't see any components on. I may have to take the PCB off this frame just to make it easier to track things through, but let's have a look. So input here probably goes down to one of these op amps somewhere. I'm sure this is a class D amp. We're going to prove it now. So what's this chip here? Yeah, straight away. So that is the MOSFET driver. I know this chip quite well now. Pin 3 will be the input from the pulse width modulator. So that we can check. That's a good point to start. Op amp, TL072. Just moving out of the way. What's this thing? Op amp, TL072 again. Chip over here. Oh, this is a bridged amp. I bet it's another one of those drivers. Yeah, there's the other driver. So there's one for each bridged amp. So this is one amplifier. This is the other one. Bridged. Another chip here. Is this another one of these TL072? Yeah, TL072. So three TL072s I can see. Don't see any other ICs, to be quite honest. Couple of transistors, the same on that side. So we have two amplifiers which are basically the same as each other, and a little bit of circuitry which is common to the two. So that in itself shouldn't be too difficult to work on. Okay, let's get this thing powered up and let's start off straight away on the input to the pulse width modulators. That will give us a kind of like a halfway house on this so we can see where the problem is likely to be. Here's the data sheet. IRS 2092. In fact, on this one, pin 3 is literally the audio in. There are some similar chips where that is a PWM in, and this effectively has a separate chip converting from the analog to the PWM, but in this case it's all integrated. So really, this is a Class D amplifier on a chip, yeah? Integrated analog input Class D audio amplifier. So the point I mentioned, which is pin 3, is a very good point to start looking on this if we're going to diagnose a fault. So if we have audio coming in here on this pin and no drive going to the MOSFETs, or we can just check on the speaker out, then there's the problem. The other thing with this is that with no audio input at all, you should have a 50% duty cycle on the speaker out there, okay? Let's have a look to see what we have. I'll just show you how this is connected. So I have the power supply on here. This is the mixer board. I have audio connected coming in. I have the power connected coming in, and the amplifier is on the bench. So it's easy for me to work on. Just position it a little bit. There you go. So we'll go with this one first. I mean, both amplifiers should basically be the same. But let's look at this one first. This is a mono amplifier, by the way. They just connected as a bridge. Ground. Scope. So pin 3 is where I'm interested. Which actually, I think it goes to this capacitor. Looks like it. Quick continuity test. Pin 3. No, not that one, that's pin 4. Where does it go? It's not really a problem. I can probe on pin 3, but if I find somewhere easier, all the better. It goes there, okay, it goes there. You can hear it, I'm sure. You can also see it now as well. So pin 3. Yep, goes there. So it's best to probe here. I can't really slip so easily with the probe from there. Scope probe on the capacitor then. Switch it on. It's powered up. I have the green signal light on. What do I have here? Was that the 40 hertz? Where's it gone? Not sure that is. Signal coming in from the mixer. I can see it. Auto. Yeah, there's a signal coming in from the mixer. Yeah, 30, 40 hertz onto our chip. No, there's just a DC voltage on there. Okay, I could probe the other one. It's a bit more difficult to get at, but I don't really need to because I can see what's happening. Okay. So do I have anything on the speaker output at all? Let's have a look. I'll go to times 10 because it could be quite a high voltage. Okay, speaker outputs. Well, I'll put it onto AC as well. AC coupling. Okay, so I'm only interested to see if there's a signal. No. No. So I don't have an audio signal getting to here. I have a DC voltage on it, and on the two speaker outputs they just have I think they have a DC level on actually. See, although that was to ground, so they possibly don't have a DC level between them, which is the important thing. Okay, let's have a look. So this is from one speaker output to the other one. No, there's no DC offset. Okay, so there's definitely no audio signal getting as far as that one. Can I easily probe the other one? Sorry guys, I'm kind of behind that. Let's see. It's a bit awkward, all the stuff on the bench. Pin 3 goes to this capacitor, okay? I'll go back to 1 times again, a bit more sensitive. I'm on probably a bit blurred for you guys, but 100 millivolts per division. Okay, so that's the end of this capacitor here. We can see where it is, just there. Okay, let's power this up again and see what we have. Well, straight away I can see there's actually a voltage on there. I'm going to go to AC coupling again, guys, just so I can see a bit more clearly without it going off the end of the screen. Okay. Right, there we go. What do we have? Auto. Oh, well, so just get the trigger on that. We have a very small signal, about 50 millivolts, extremely small. And back on the other one, the same. Compared with the input signal, yeah. So we do have something getting through there, but it's extremely small, that signal. But the other thing is that without any audio signal coming in, the chip should be running basically with a 50% duty cycle on the output. It doesn't seem to be doing that either. Okay. I've disconnected the signal. No signal coming in now. Let's have a look on the outputs from this chip. Okay, so back to the schematic or the typical application. I think there's another one further down as well. Yeah, like a little bit more detailed. We can see that 14 drives the high side MOSFET gate via a resistor, and 11 drives the low side via a resistor. These MOSFETs were blown on at least one channel, so that could easily have actually blown these chips up. Let's have a look to see if we can find an easy point to probe on the 11 and 14. So with no audio signal coming in, these should be running to 50% duty cycle, so that the output here is the same voltage as ground halfway between the two supplies. Okay. I can't see a point to probe at unless I can get down to the gates of the MOSFETs, which are actually not totally easy to get to because of this heatsink. So I'm going to probe on here. Normally when I'm doing this, I like to get the scope probe onto the point first and then switch on. I'm less likely to slip with the scope probe if I do it this way. And what do we have? Well, we don't really have anything, and that should be a high frequency square wave. Okay, so if there isn't one on the low, that's my finger, by the way, on the scope. That's 50 hertz. Yeah, that's just me. Okay, so if there isn't one on the low, then it doesn't really matter if there's one on the high anyway. Okay, so that chip is not working. Do I have any of these? Yeah, I do have some of those in stock. I have, looks like 3 in here, and it looks like I need 2 of them. So that I have. But before I change those, I want to have a look a bit further back, because I have the strange thing with the voltage on here, which doesn't seem to be right, that 8 volts. And that's going to go via possibly these transistors. Might be some sort of differential input, and then the op amps. Bear in mind that one of the Class D amplifiers also have an inverted signal to the other one because it's a bridge. Okay, but let me see if I can just have a look around these op amps, see if I can figure out the signal path, because I might have a fault here as well. I've disconnected the amplifier board now from the power supply. It's all disconnected. So this channel has one more op amp here than that one. Knowing that one of the amplifiers will have an inverted signal, that is probably something to do with that. And then U2 and U6 are driving the channels. Probably, this is a lot of supposition. Okay. That one, is that damaged? It might be. Yeah, this one. You know, I think that's actually got a crack in it. Let's see. Well, it doesn't clean off, that's for sure. It does not clean off. That looks suspicious to me. Yeah. Look at that. Okay, let's see if we can just take some measurements in diode mode. So these are JFET op amps. Okay, I'm confident I don't have these, but we'll check in a minute. So this is the package, dual op amp, JFET input. So the standard sort of pin out, 3, 2 and 1, 5, 6 and 7 are the two op amps, with 1 and 7 being the output. Let's compare them all to each other in diode mode. This technique may not be totally conclusive, but it's worth doing. So in reverse polarity, with the positive meter lead to the negative supply pin, this is an input, reads 0.623, 0.623. They all read the same. That's kind of what I would expect. But that one reads different on the output. Completely different. Let's look at another one, because I have 3 of these on the board. So they're on the other side. So this is in the same position in this amplifier as the one we were just looking at. So red to here. 563. 611. So they read a little bit different, but not much. That reads totally different. And then this one, 619, 619. That also reads like that other one, to be honest. So I say this is not always conclusive. Okay. And the other one down here, same thing. 620, 620. High. So these like do read high, apart from the other first one I tried. Okay, so 549, 612. High. No, that reads lower. So I don't get any conclusive readings. I mean, there are diodes and things around here, so we can say that, but it's fair to say that these two really are in the same place in each amplifier, and they should read, you would assume, the same, notwithstanding this seems to have the inverting one down here. And 567, 610, 1170. Six two one, 621, 621. Definitely different. And it's the output which is different, which is feeding that way, you would assume. Okay, and this side, 618, 618, 1182. And here, 624, 624, and high 1182. That reads about the same, but we definitely have a difference on the output of these two, which makes me suspect at least one. I mean, that's the one that looks like it's damaged and reads differently. What about these transistors? So these are down near the input somewhere. Well, that's a TL431. That's a voltage reference. I've got those. Okay. This one is another voltage reference. We have two of those. Assume these will be the same. Yeah, TL431. TL431. So they're all voltage references. Let me see if I've got these TL072s. No, I don't have the TL072s. I thought I might have had some DIL ones, so I can at least just look at the readings out of circuit and just see how they compare with these, but I don't have at all. What else can I just check on around here? some diodes down here, probably clamping diodes of some sort. Reads like a diode. Reads like a diode. Reads like a diode. Reads like a diode. Few more up here. Reads like a diode. These big ones. I think I checked these when I checked changed the MOSFETs actually. Okay. I think that's all we have there. This end reads okay. Reads okay. Yep. The smaller one here reads okay. Right. Decision time. I have these in stock. I only have 3 left, so I'll order some more anyway because I like to keep them in stock. Given the fact that reads different to that, and these should effectively be identical circuits, really. Plus the fact that looks like it's cracked tells me that needs changing. I might as well change all of the TL072s. The TL431s I can unsolder and test. I have a little tester, I can show you how to do that. If any of those are faulty, then I can replace them. I have them. Those look okay. So I'll get the chips. I don't have these TL072s. Let's get 10 or 20 of them. And then we'll change all of the chips, 5 chips. As I say, we'll test these TL431s. And we'll try it again. Everything else looks pretty okay. Don't spot anything I should have looked at, really. Possibly these high wattage resistors are worth a check because they do tend to fail, as I have discovered. So 2K, yeah, 46.4K, yeah, some capacitor charge, and then it's settled very, very close to that. Look at that. 46.4 exactly, okay. Same with this one. Close enough. 2K, yeah. I'm suspicious of these days because I've seen these, and you have if you watch my videos, fail without any indication that they've failed, okay. Right, yeah. So that's that on that one, guys. I'll get the parts ordered, so you'll see this again. I mean, you've seen this damn thing enough times already. I am determined to fix it, one fault after another. But in the meantime, hey, anything else you suggest, we can check, and if it looks like it's faulty, I can order. Okay? Another job half done. But hope you enjoyed this anyway. Look forward to seeing you all again soon on the Electronics Repair. Ciao for now, guys.